Hey everybody, this is Miss Berry. In this video, I'm going to go over section 1.3, which covers polynomials and factoring. I'm going to turn my screen around and share my screen with you now. All right, so polynomials and factoring. So the first thing that we need to talk about is just some terminology. Whenever we're dealing with polynomials, you'll keep hearing me refer to certain vocabulary words, and I want you to know what I mean by that. So starting here, I just picked this random polynomial. It's nothing special or fancy. It just says, this is how I would read it: 4x cubed plus 5x squared plus 16x minus 6. All right, so this is a polynomial. Poly means multiple. It just means it's made up of multiple terms and they're being added or subtracted. All right, so the first term, well, first of all, I should point out that this polynomial is written in descending order. That means that the exponents on our variables, the exponents are going down. So we have 3 as our exponent on the first term, 2 is our exponent on the second term. There's a little invisible 1 on that x there. And then this is our constant term. All right, so the last one is called our constant term. And that just means it's a number. Doesn't have a variable. This term here is called our leading term. The leading term is the term or the piece of the polynomial that has the largest or the greatest effect on the shape and the size of the polynomial. More specifically, you will also see the coefficient in front of that variable. They'll refer to this sometimes as the leading coefficient. All right, so if your polynomial is written in descending order, that's where the exponents are decreasing every time. Then you can call that first term the leading term, and you can call the coefficient out front the leading coefficient. All right, a couple more things and then we'll move on. Whenever you identify the leading term and you look at the exponent here, that tells you what we call the degree of the polynomial. So this polynomial, let me not use green in case anyone's colorblind. This polynomial, we would say, has degree 3. All right, so the degree refers to the highest or the largest exponent. All right, so this is a degree 3 polynomial. And it's important to note that even if this was mixed up, like if I had written it as 16x plus 5x squared plus 4x cubed minus 6, I just wrote those in a random different order, this would still be a degree 3 polynomial. You're always looking for the highest exponent, right? So, or the largest exponent. So this is still a degree 3 polynomial, even if you write it in a different order. All right. Let me try to think if there's anything else I want to tell you. Sometimes you'll see polynomials written in ascending order. It's pretty rare, and I'll never ask you to put an answer in ascending order. So ascending order would be where you start with the constant term and the exponents get larger each time. So in this case, ascending order would look like -6 plus, -6 plus 16x plus 5x squared plus 4x cubed. So just, the reverse order of descending order. The reverse of descending order, I should say. All right, I think that's everything. So the degree is the highest exponent. The constant term is the part of the polynomial that does not have a variable. whenever you put the polynomial in descending order with the, the exponents decreasing each time, the first term is called the leading term, and specifically the number that's out in front of that variable is called the leading coefficient. And then ascending order is just the reverse of descending order. All right, so I think that's all the terminology you need to know. There might be a couple more things that we pick up along the way. All right, so here's a couple of those things naturally. It comes right up. So monomials, binomials, and trinomials, really basic and straightforward here. Mono means one. So this is a polynomial with only one term. Right, so some examples would be like 2x or -4, or let's do -1/5 x to the third. All right, so monomials only have one term. Binomials have two terms. Bi means two. All right, so binomials is going to be like x squared plus 5x, or -3x to the fourth minus 10x squared. Just making these up. Trinomials, that's what we're going to see the most of. Those have three terms, of course. Tri means three. This is going to be like what we're used to seeing with the directions, say, in factors, something like x squared minus 5x, let's say plus 20. All right, so trinomials have three terms. And a lot of times you'll see trinomials with the directions that say factor completely. All right, so we're going to talk about factoring. We're going to kind of ease into it. We're going to do some really basic factoring. We'll talk about some special factorizations, and then we'll get into the more difficult factoring. All right, so here we have some more work with just basic terms of polynomials. All right, so we have, it says consider the following polynomial: 7y squared, or excuse me, 7y to the 12th minus y to the 8th plus 9 plus 2y to the 5th. So this is definitely out of order, right? We do have the largest exponent listed first, but everything else is out of order. So it says express the polynomial in descending order. So let's do that first. So highest exponent, that's that 7y to the 12th. Notice how I'm keeping everything together. The 7 stays with the y, which stays with the exponent of 12. Minus y to the 8th, so that one's in the correct order. But then this 9 is in the wrong place, so it needs to go to the end because that's the constant term. So then we're going to do plus 2y to the 5th plus 9. Just make sure you can tell that's a minus. All right, so now the polynomial is in descending order, and it's asking us to identify the degree. Remember, the degree is the largest exponent, so try to think for a second, what do you think the degree is? All right, what's the largest exponent here? It's 12, so we would say this is a 12th degree polynomial. The degree is an important part of, an important part of the polynomial, because it's going to tell you how many x-intercepts you have. Right, so it's very useful. And then here you can see I've misspelled identify. It says identify, but it should say identify the leading coefficient. So what do you think the leading coefficient is? Remember, the coefficient is just the number in front of the variable. All right, so if you said 7, that is correct. So the leading coefficient, that's the number, the leading term. You look at the leading term and then you identify what is the coefficient on that leading term. So that is 7. All right. So we're going to start with some basic operations of polynomials. All right, so we're going to talk about addition and subtraction, and then multiplication. We'll save division for later on in the semester. That gets its own section. Adding and subtracting polynomials is just all about combining like terms. You've probably heard those directions or instructions before. All you're doing is just combining like terms. All right, so here we have negative 4x cubed y plus 2xz minus 3y, that's in one little set of parentheses, that's its own little group, plus 2xz plus 3y plus x squared z. All right, when you're adding, you can drop the parentheses. All right, so I'm just going to rewrite this. You don't have to. If you're doing this on your own paper, you may choose to not rewrite this step just to save yourself a little bit of work. That would be totally fine. You can see I put the line through my z's because they look pretty much just like my 2's. So I put the line in the z so you can differentiate it from the 2. All right, so we've dropped the parentheses and now we just need to go through and match up our like terms. So first thing we're going to look for is, does negative 4x cubed y have a like term? So what do y'all think? Do y'all see any like terms here for that one? Like terms would mean that the variable aspect matches completely. So we would need to look for another x cubed y term. So we don't have any other x cubed y terms, so we're going to go ahead and just drop that term straight down. All right, now we're moving on to the 2xz. Do you see any other xz terms? We do, right here. Just went ahead and highlight or underline that plus as well so we can tell if it's positive or negative. All right, so when you're combining these like terms, you're just going to add their coefficients. So 2, positive 2 plus 2, that gives us 4. So plus 4xz, keep the variable aspect the same. All right, then let me switch to a different color. Negative 3y, looking for a like term there. We got a positive 3y. So negative 3y plus 3y, those are actually going to cancel each other out. All right, and then our last term, x squared z, no like term, so it just gets dropped down. X squared z. Now, this is not in simplest form, but they did not ask us to simplify, so we're not worried about that. All they asked us to do was to add or subtract the polynomial as indicated. All right, so let's put a little note here. This is not simplified. This is not simplest form. We'll talk about in a little bit how we could make that into simplest form. But just for our purposes, we just want to note that this is not in simplest form, but they did not ask us to simplify, so we don't have to take it any further than that. All right, so next we have a subtraction problem. I'm just going to get this one started for you just so I can keep the video short. But this is very similar. The only difference is that this time our operation is subtraction, and that means we need to be really careful here and make sure that we distribute the negative. That's one of the most common mistakes in this class, is forgetting to distribute the negative. Right, so a ton of simple mistakes result from forgetting to distribute the negative. All right, so what do I mean by that? What that means is that everything that comes after the negative gets distributed that little negative. So everything up here is fine. We're just going to drop it straight down. Everything that comes after the negative, we're going to distribute the negative to each one of those terms. All right, so minus 4, minus negative 6x, minus negative 3x squared. So you want to make sure that you're subtracting each term from that second group, not just the 4. So a common mistake is just to say, okay, I'm going to drop the parentheses, and that's just going to become 5x squared minus 6x plus 2, and then just minus 4 minus 6x minus 3x. But in that case, you would be just subtracting the 4. We want to make sure that we subtract everything. All right, so go ahead and switch those double negatives to positives. And then from there, it's the exact same as what we just did. All right, so then you're just going to combine like terms. All right, so like I said, I'm going to leave that for you to do so we can try to keep the video as short as possible. Multiplying polynomials, you probably learned this as the FOIL method. FOIL stands for first, outer, inner, last. And this is just so we have a pattern to follow. You can multiply in any, if you wanted to like really have some like chaotic energy, you could like multiply these in a different order. But the FOIL method just gives us an order to follow so that we make sure that we get every term accounted for. All right, so 5x minus y times 2x minus 4. First means we're going to multiply the first term, so these guys. All right, so 5x times 2x. You're multiplying coefficients, multiplying variables. All right, so 5 times 2 is 10. X times x is x squared, adding the exponents. All right, so first and then outer. So the outer terms would be the 5x and the negative 4. All right, so 5x times negative 4 is negative 20x. All right, then we're doing the inner terms. All right, then we're doing the inner terms. Negative y times 2x. Oh goodness, let me fix this before I write this down. I don't know why it wanted to give me a weird dotted line. All right, so negative y times 2x, that's going to be, I like to put the variables in alphabetical order. That way I just do it the same way every time. So I'm going to do negative, imagine there's like a 1 there. Negative 1 times 2 is negative 2. And then y times x is, I'm going to do xy so that it's in alphabetical order. All right, so first, outer, inner. Now we're doing last. All right, so the last terms would be the negative y, or the negative 1y as we have it written, and the negative 4. So negative 1 times negative 4, that's going to give us a positive 4. Negative times a negative is a positive. And then our y times, there's no variable here, so it just becomes y. All right, so I feel like I over-explained that. You probably already knew how to do that. But if you haven't seen the FOIL method in a while, hopefully that helped. All right, so 10x squared minus 20x minus 2xy plus 4y. And again, you do not see the directions to simplify here, so just leave it just like that. In fact, if you try to simplify and you factored it, it would just bring you back up to the original problem. So we definitely don't want to simplify in this case. All right, so here we have our special product formulas. I don't really care about having you memorize these. This is not something that I would personally put on my formula sheet. But some people like to have this information. So this is our special product formulas. A minus B times A plus B. If you FOIL that out, that's going to give you A squared minus B squared. A plus B, all in parentheses, raised to the second power. You would really write this out as A plus B squared is the same thing as A plus B, times A plus B. And if you FOILed that out, it would get you to A squared plus 2AB plus B squared. And then similarly, if you have A minus B quantity squared, that is really the same thing as A minus B times A minus B. Then you're going to FOIL that out. That's going to get you to that A squared minus 2AB plus B squared. So you can see the only difference here is that second sign, or that first sign, excuse me. The sign on the middle term is the only difference between those two. All right. Here we have another multiplying problem. Again, I'm just going to set this one up for you. I'm not going to work it all the way out. It says find the product of the binomial factors using the appropriate special product, difference of two squares, square of a binomial sum, or square of a binomial difference. You do not need to use the formula. You can if you want to. If you wanted to, you would be using this one because it's addition. All right, so x plus 6 squared. If I was doing this on my own, I would just take the couple of minutes that it would take to just FOIL that out. And it gives me one less formula to memorize. All right. And I think if you multiply this out, if I can do it in my head really fast, that would be x squared plus 12x plus 36, if you want to check your answer. All right, GCF. Here we are getting into the actual meat of the section. All right, so GCF stands for greatest common factor. The greatest common factor is the product. Wait, hold on. Back up. It says the greatest common factor among all the terms is the product of all of the factors common to each. Excuse me. For example, if you have the polynomial 12x to the fifth minus 4x squared plus 8x cubed z cubed, you would look at this and say, okay, I'm going to start by looking at my coefficients, 12, -4, +8. You would say, what number goes into all of those? 2 goes into all of them, but even you want to get the highest number possible. So the largest number that goes into all 3 would be 4. All right, so 4 is going to be part of your greatest common factor. And then you take a look at the variable parts. And you say, okay, I got x to the fifth, x squared, x cubed, z is random, that's down there at the end. We don't have any other z's, so we're just focusing on x's right now. So we would say, okay, this one has 5 x's, this one has 2 x's, this one has 3 x's. That means that there are 2 x's common to all terms. So each term contains 2 x's. So we could pull that out. All right, so if you pulled out 4x squared, put parentheses around it, and then you're going to write what's left over. You're really dividing by 4x squared. So think of it that way. You would do 12 divided by 4 is 3. If you have 5 x's, you take away 2. How many are left over? Also 3. All right, -4 divided by 4 is -1. Do we need to write the 1? No, we don't have to write the 1. You can leave it off. If you add it on, in my opinion, it would not be wrong, but Hawks would probably count that as being incorrect. All right, so 2 x's take away 2. Nothing left, it's just a 1. So no x's left, I should say. All of your x's cancel out. And we're just left with -1. All right, and then here, if you have 8 divided by 2, that's a +2. 3 x's take away 2, that leaves you with 1 x, and then these z's have to drop down as well. All right, so that is the greatest common factor. That's how we remove or factor out the greatest common factor. It's an important skill to have whenever you are trying to factor polynomials. All right, so let's take a look at one more. Let's see, do we want to do? Yeah, we'll do this one. 12x to the fifth minus 4x cubed plus 8x. I didn't mean to choose the same coefficients. That was just a coincidence. All right, so what number goes into 12? What's the largest number, I should say, that goes into 12? -4 and 8. Again, that would be 4. You could factor out a -4 too. That would not be incorrect if you pulled out a -4. You just don't have to. Makes it a little bit less work on yourself if you don't factor out a -4, because then you have to remember to switch the signs if you factor out a -4. Oops, I forgot to look at our variables. All right, so we got x to the fifth, x to the third, and x. How many x's should we take out? What's common to each? They each have an x, right? That's the largest amount that we can take out. All right, so if we divide by 4x, 12 divided by 4 will be 3. 5 x's take away 1, that'd be x to the fourth. -4 divided by 4 is -1. 3 x's take away 1, that's x squared. All right, so I'm going to leave the 1 off. 8 divided by 4 is +2. X take away x, all the x's are gone. All right, and there you have it. That is our factored polynomial. You can double check just by looking inside your parentheses here. Make sure that there's nothing left in common. 3, -1 and 2, those have no common factors. And then we have 4 x's, 2 x's, and no x's. So we know that we have pulled out everything that we possibly could. All right, so I'm trying to be brief as possible because I know the longer the video, the less likely you are to finish it. Factoring by grouping. All right, so factoring by grouping is going to be really easy to spot these problems because they're always going to have 4 terms. All right, so anytime you see a polynomial and it's got 4 terms, you know you're going to do factoring by grouping. All right, so factoring by grouping is just very straightforward. It is exactly what it sounds like. You're going to group the first 2, you're going to group the second 2, so factoring by grouping. All right, so whenever you group the first 2, just for a second, you're going to totally ignore, goodness, let me see if I can make this a solid naturally. It doesn't want to work for me. Yeah, I was trying to block that out. That was an epic fail. Get out from my page. Okay. My goodness. Okay. Whew, close one. All right, so we're just going to ignore these second 2 terms as we look at the first 2 terms. All right, so just don't even look at this second group. Just look at the first group. It says ax minus 5bx. So when you look at those, can you tell what they have in common? What do those 2 terms have in common? No number factor in common, right? This one is just a coefficient of 1. This one's got a -5, so no coefficient in common. But they do have an x in common. All right, so we can pull out an x. All right, so divide everything by x or take out an x. All right, so we have ax. If you took out x, it's just left with a minus 5bx. If we take out x, that just leaves you with 5b. All right, now we're going to focus on the second group. Again, totally ignore the first group. Just don't even look at anything over here. We're just looking at the 5ay minus 25by. All right, we're saying, okay, what do those 2 terms have in common? We have a 5 and a -25, so we could pull out a 5. And I want to just note that it's a +5 here. That's going to be important in just a second. You'll see why I did that. All right, so, oops, again, I'm getting ahead of myself. +5. And do they have any variables in common? They have a and b, so those aren't in common. But they do both have a y, so let's pull out a y. All right, so divide everything or take out the 5y. 5 divided by 5 is 1. We'll see if we need to leave it in there or not. A just stays, so we do not need that 1. The only time you want to leave the 1 is if the variables also cancel out. Y, take away y. All right, so those just cancel out. Or excuse me, I should say that cancels out. All right, so -25 take away 5 or divide by 5 would be -5. by divided by y just leaves you with b. All right, so now I want you to look at this. A minus 5b, a minus 5b. All right, so this should always happen if you are successfully using the factoring by grouping method. All right, so you should always end up with the same thing inside both those parentheses. All right, and what that creates is like a common factor. So here we have x times a minus 5b, and then we have 5y times a minus 5b. All right, so that common factor, a minus 5b, gets pulled out front. Now, in the second set of parentheses, we're going to write what I like to call the leftover stuff. All right, so the leftover stuff is going to be what's here and here. All right, and that's why it's important that you put that little plus on there, because that's going to help you form that parentheses with the leftover stuff. All right, so x plus 5y. Let me switch back over to my pen. X plus 5y. That's our second set of parentheses. And there you have it. That is our factored polynomial. All right, so just to remind you, keeping this vocabulary fresh in your head, monomials have one term, binomials have two terms. This would be a little binomial. This would be a little binomial. Trinomials have three terms. Anything with more than three terms, we're just going to call that a polynomial. So ax minus 5bx plus 5ay minus 25by, that's a polynomial because it has four terms. All right, so anything more than three terms, we're just going to call it a polynomial. All right, so let's see. I'm going to stop the video here and then make a second video for the second half of this section so that you can break it up and not have to watch a whole hour-long video at one time. But I will come back in the next video and talk about special factorizations and how to factor trinomials. All right, thanks for watching, and let me know if you have any questions.